In this topic, for class 10, we study first of all about force. What is force? It is defined as that external agency which changes or tends to change the state of a body, position or state of a body. This external agency is called force. Its SI unit is Newton, CGS unit is Dyne. In class 10, you have to study about gravitational force, especially about gravitational force, gravity. Then, what is meant by gravitational force here? Gravitational force means the force of attraction between any two bodies in the universe. There exists a force of attraction between any two bodies in the universe. This force of attraction is called gravitational force. Just like suppose two bodies are here. One has mass m1, other has mass m2, and the distance between them is d taken. F is the gravitational force between them. This force is calculated by a formula F equal to G into m1 into m2 by d square, where the term capital G represents universal gravitational constant. It is called universal gravitational constant. Its value is 6.67 into 10 power minus 11 Newton meter square per kg square in SI system. The value of capital G is universal gravitational constant. It is a constant all over the universe. Therefore, we say it universal gravitational constant. Here, according to this formula, the force of attraction or gravitational force between two bodies depend upon these three factors, means masses of the two bodies and distance between them. According to Newton's law of gravitation, the gravitational force between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Just like we can say that F is directly proportional to m1 into m2, masses of the two bodies. Gravitational force is directly proportional to the product of masses. First statement, and second is F is inversely proportional to the square of the distance. It means that if masses are increased, gravitational force between them increases, and if distance between two bodies increases, then gravitational force decreases. This is the relation, and from this we can derive this relation F equal to G m1 into m2 by d square. Here, in this topic, we have to study about Newton's law of gravitation. Newton's law of gravitation. What is Newton's law of gravitation? Newton's law of gravitation, it is also called universal law. According to this law, there exists a force of attraction between any two bodies in the universe, and this force is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This means that here mathematically we can write F is directly proportional to product of masses and inversely proportional to the inversely proportional to the square of the distance between them. It states that there exists a force of attraction between any two bodies. Between any two bodies in the universe. Bodies in the universe. This force is directly proportional to the product of their masses and inversely proportional inversely proportional to the square of the distance, square of the distance between their centers. Mathematically, we can write f is directly proportional to m1 into m2 and f is inversely proportional to the square of the distance, d square. Now, this Newton's law of gravitation is called universal gravitational law. Universal law because this law holds true for all the objects existing in the universe. It is true for terrestrial bodies as well as for celestial bodies or heavenly bodies. Similarly, it is true for teeny objects as well as for massive objects, very big objects. Therefore, we say that this law is universal law. Now, from this, we can derive this relation f equal to gm1 into m2 by d square. Then, how can we prove this? Just like you require this figure to explain. First of all, we explain about the same figure. Here, redrawing this. Two bodies A and B have masses m1 and m2. These are the centers and D is the distance between their centers. F is the gravitational force. We have to prove this relation. F is equal to G m1 m2 by d square, where the symbols have their usual meanings. Usual meanings means to say m1 and m2 represent the masses of the two bodies and d represents the distance between their centers. D, small d, is the distance between their centers. To prove this, let two bodies A and B of masses m1 and m2, masses m1 and m2 are placed at a distance d apart from their centers. From their centers, let F is the gravitational force. F is gravitational force between them. Then, as we know that Newton's second law is here, that according to Newton's law of gravitation, you know that F is directly proportional to product of masses and F is inversely proportional to square of the distance between their centers. So, combining these two relations, combining 1 and 2, you can write F is directly proportional to product of masses inversely proportional to the square of the distance. Therefore, you can write F is equal to, here proportionality sign is given, and to convert it into equality sign, you have to add any constant. So, especially capital G, this is universal gravitational constant, this term is to be taken, and G m1 into m2 by d square, where you have to write here about capital G, where G is called universal gravitational constant. Universal gravitational constant. Its value is constant all over the universe, and G equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. In this way, you can prove this relation here. It is clear that gravitational force depends upon two factors: mass of the two bodies and distance between them. Now, just the next term is here about capital G. How will you define about capital G? How will you derive the unit of capital G? In this topic, we explain about the same thing. Here, if M1 equal to 1 kg and M2 equal to 1 kg, means to say two bodies are here, each of mass 1 kg and distance between them is also 1 meter. If this type of data is given, distance is equal to 1 meter. In this condition, what will be the amount of gravitational force? Then we can write F equal to, as we know formula, Gm1 into M2 by d square. This equal to G into 1 by 1 square. This gives capital G, F equal to G. In this condition, capital G will be equal to the gravitational force, means universal gravitational force. Universal force means gravitational force will be equal to universal gravitational constant. So you will be asked, define universal gravitational constant. Then how will you define? Universal gravitational constant is defined as the gravitational force between two bodies of unit masses separated by a unit distance between their centers. In this way, you can define capital G. Now, you can write universal gravitational constant. Universal gravitational constant. It is defined as the gravitational force. It is defined as the gravitational force between two bodies. Gravitational force between two bodies of unit masses separated by a unit distance from their centers. In this way, we can define about capital G also. Now, what is the unit of capital G? As you have taken Newton meter square per kilogram square, then how can you find the unit of capital G? Here, to find the unit of capital G, unit of capital. As we know that F is equal to G M1 M2 by d square. Okay, here, as you know, cross multiplication, FD square equal to Gm1 into M2 by M2. This means capital G equal to FD square by M1 into M2. Now, we can use their SI units in the given term using SI units. Using SI units, in this relation, force is here, that's why we take Newton, distance, then meter, there is a square, so we take a square by mass, unit of mass is kilogram, and here also is kilogram. These two are the masses of the two bodies. This implies Newton meter square per kg square. Newton meter square per kg square. In this way, we can obtain the unit of universal gravitational constant also. Now, suppose numericals are asked related to two masses and you have to find the distance. Very simple numerical is, if you have to find the gravitational force between two bodies, then how will you obtain? Just like suppose two bodies, masses, two bodies of different masses are given, one 10 kg, other 20 kg. And you have to find the gravitational force between them 10 kg. One mass 20 kg, another mass 10 kg, 20 kg. Suppose these two are separated by 5 meter and you have to calculate the gravitational force. Yeah, in each and every numerical, capital G equal to 6.67 into 10 power minus 11 Newton meter square per kg square. This should be taken as it is universal gravitational constant. Then numerical. If two bodies of masses 10 kg and 20 kg are placed at 5 meter apart, calculate the gravitational force. Gravitational force between them. Very simple numerical it is because all the data are given and just you have to calculate force. Here, masses of the first body. This is M1 or M2, whatever can be taken. M1 is 10 kg and M2 is equal to 20 kg given. Distance between them is d. This is equal to 5 meter given and capital G is 6.67 10 power minus 11 Newton meter square per kg square. You have to calculate the gravitational force. Then by formula you can write F equal to G M1 M2 by d square. F G 6.67 10 power minus 11 M1 10 M2 20 distance is here 5 square. This we can write 5 into 5 also 2 times 5. Calculation is required. Here 5 4 5 2 2 4 8. So 6.67 into 8 into 10 power minus 11. This is equal to 7 8 53.36 into 10 power minus 11 Newton, and this can be taken 5.336 into 10 power minus 10 Newton. This is your final answer. In this way, very simply we can calculate the gravitational force between two bodies. Here, effects of gravitational force. There are so many effects of gravitational force in our daily life you can see or you can feel also. Just like planets revolve around the sun, this is also due to the gravitational force between sun and planet. Similarly, sometimes tides occur in the sea or ocean. This is also due to the effect of gravitational force. As you know that construction of building is due to the effect of gravity. Here, gravity is especially the gravitational force between any planet with the object. Here Earth is considered as the planet. Gravity is also a special case of gravitational force where one object is the Earth. Similarly, when an object is thrown upward, it again falls towards the Earth. This is also due to the effect of gravitational force. In this way, there are so many examples as we see in our daily life about the effects of gravitational force. Now, there are some of the relations between gravitational force with their factors. Their factors are masses, relation between gravitational force, with their factors. Relation between gravitational force with their factors. Just like what changes will occur if masses are double. Suppose first object, second object. These two are taken. E is the distance. This is the first mass and this is second mass. F is gravitational force Here in this case we say suppose F1 is the gravitational force. Case 1. Let M1 and M2 are the masses of two bodies. And D is the distance. This distance between their centers. Then, case 1, as you know, F equal to G M1 into M2 by D square. First equation. Now, if masses are doubled, when masses are doubled, then what change will occur? When masses are doubled, in this condition, M1 equals 2M1, M2 equals 2M2. If masses, which both masses are doubled, suppose this is 2 kg, that will be 4 kg. If this mass is 5 kg, that will be 10 kg. According to that, if masses are only doubled, then M1 equal to 2M1 and M2 becomes equal to 2M2. In this case, the gravitational force changes. Let that force here and distance is kept constant. Here distance is constant, means no change in distance. Therefore, in this condition, the force will be G into 2M1 into 2M2 divided by D square of the distance. So 2 2 is 4. 4 into GM1 M2 by D square. So we can write 4 into this term GM1 M2 by D square is equal to F1 using relation 1. So in this case we see that if masses are double, the gravitational force increases by 4 times. Is it clear? Yeah, 2 2s are 4 into G M1 into M2 by D square, and this term is equal to F1 according to equation 1. So we can write that if masses between two bodies, masses of the two bodies are double, then the gravitational force is increased by 4 times. Now, if distance is changed, suppose distance is changed, distance is double. Case 2, when masses are constant and distance is doubled, then in this condition M1 will be equal to M1, M2 equal to M2, no change, and D becomes equal to 2D, double, means increase by 2 times. So as we know, force will equal to G M1 into M2 by distance is here 2D, therefore 2D is square. This is equal to 2 2 is 4, 1 by 4 into G M1 into M2 by this term is D square. So you can write 1 by 4 and value of this is equation 1. You can write G1 M2, this is equal to F1. Therefore, in this condition, F1 by 4 means to say that the gravitational force decreases by 4 times. This means we can be clear from this relation that if distance increases, gravitational force decreases. Now, if mass in the third condition, if masses are also double and distance is suppose half, then what change will occur? Case 3 or relation 3. In third case, case 3, if masses are doubled and distance between them is half, then what change will occur in the gravitational force? This case has been asked in SE examination also. Here, masses are double. Masses were M1 and M2. So M1 will be in this case 2M1 and M2 is equal to twice that of M2. Distance between them is half. Here distance was taken D in the first case. Now in this case D will be equal to half of this previous case. So D by 2 as given. Half of the previous. Yes. So in this condition F equal to J M1 into M2 by D square is your relation. Therefore in this relation you can write G into M1 in place of M1 2M1 into in place of M2 2M2 by distance D by 2 is a square. This is equal to 2 to the 4 into this also becomes 4 into J M1 M2 by D square, because this 2 is a square is 4, that goes up and becomes 4. So this can be written 60 into relation 1 is here F1 equal to Gm1 M2 by D square. So using this relation 1 we can write F1. So we can write F equal to 60 F1. It means that if masses are double and the distance between them is half, gravitational force is increased by 16 times. Here, two questions are given related to the topics that we have taught. In this first question, mass of the sun is given and that of the earth is also given. Distance between sun and the earth is also given here 1.5 into 10 power 11 meter. You have to calculate gravitational force between them. Similarly, in the second question, you have to calculate universal gravitational constant. Mass of Jupiter is given. Similarly, mass of sun is given. Gravitational force between them is given. And the distance between Jupiter and sun is 7.8 into 10 power minus 10 power 11 meter. Two questions are given here, and you can show many more questions related to mass, related to the gravitational force. You have to calculate the gravitational force somewhere, masses between masses or mass of the two bodies, similarly distance between them according to the relations that we have shown. In the next topic, I will teach you about acceleration due to gravity and other many more terms.